Power to the truth. This is Margo. This is Sunday, October 7th, 2018. And today we're going to do another sea ice update, climate cast, and I've got a few articles to share with you. And what we're looking at is the sea ice and snow cover from Climate Reanalyzer from today. We've got the northern hemisphere up here, and we're looking at what's going on with this sea ice. It's extremely warm up in the Arctic, warmer than it should be, and I'm going to be going over that in detail today. And there are areas where it's just not refreezing and not coming back as it's been expected to. And one of those areas is right up here in this northwest part, and we can see totally open blue ocean over here in the Beaufort Sea and parts of the Chukchi Sea, and this comes in from the Pacific here, and then a lot of blue ocean still all the way around on the right side of this little bit of ice that was left, and it's quite thin. We have a little bit of ice coming back on this northern part of Greenland, and the ice is either being blown towards the coast or it's refreezing, and it's coming back in these tributaries a little bit, but the Arctic is so warm. And I know if you've been following some other people who are reporting on this, the climate researchers are really up in arms about how warm the Arctic is right now, and it's extremely warm, and with that it's not going to refreeze. And I've been saying that I didn't think we would have a traditional refreezing this year because of what I've seen going on and of my own empathic visions that I've seen. So my last update was on September the 25th. So let's take a look back to where we were on September 25th, and we'll just go backwards in the slideshow, and we can see what's been going on with the sea ice from Climate Reanalyzer. Here's from yesterday the 6th. We can see this ice has been quite fragile, and when we look at this ice on NASA Worldview, it's just lacy. I mean, lots of space in between the ice, lots of blue water. So we're going back. We actually had it looks like it's melted a little bit in the last few days, where it froze back a little bit. So it's struggling. It's in a tug of war up there. So here's where the ice was on September the 25th. So, and here we are on October the 7th. So that's not quite 2 weeks, but it doesn't look much different. I mean, it's filled out a little bit down here on Greenland, and it's just been kind of moving around up there. It doesn't look that much different as far as refreezing or extent coming back, or it's coming back a little bit down here in the Beaufort Sea, but just not much. Here's October 4th. Here's the 5th, and it's actually looking thinner. And here's the 6th, and here's today the 7th. And so there's that. Next we have the Navy. Here's the sea ice thickness from today on the Navy depiction, U.S. Navy, and we can see that it's still quite thin, and this area up here on this northwest part is is thinner. It's not thicker, it's actually thinner. And we do have a little bit coming back down, about midpoint on Greenland, but it's quite thin still. And then it's coming back a little bit on the extent here, but the thickness is just not there. And what you're going to see here is their 30-day animation, where it's 3 weeks in the past and 1 week into the future, and we can see this thick sea ice, which would be aqua, not purple or blue, but aqua and green and yellow. It's still not very much at all, and we can see it moving and kind of shifting. It's coming back a little bit towards the end of their forecast period, right up here on this northern part of the Canadian islands there. But I'm going to stop this. Okay, here we are on the 5th, and I'm going to advance it slowly day by day. Here's the 6th, here's the 7th, here's where we are today, and there's just the thickness of the sea ice is quite small. Just a little bit of aqua, which is 2 to 2.5 meters, and just a little bit here on this northern part of Greenland, and here, and a little bit here on this northern part of Canada. And the rest is mainly purple and violet, which is 1 meter or below, and then a little bit of the blue and going into the darker blue, which is 1 meter to 1.5 meters. So that's where we're at. And then this is their prediction on what it's going to happen in the next 7 days. But they don't know. They really don't know what's going to happen. Hang on a second. Okay, I'm back. So they really don't know what's going to happen in with this refreeze, because, you know, in the articles that I've shown in the recent past, there's warmer water coming in from the Atlantic and from the Pacific, and it's quite warm, and it's also salt water, and it's mixing with the fresh water, and it's coming up underneath this frozen sea ice, and it's making it warmer underneath, and so it's actually keeping it warm underneath, so it's harder to refreeze, and it's actually melting from below. And so when you have a warm air surface temperature as well, the ice is having a hard time coming back. It's fighting to come back. So next I have a climate reanalyzer. We're going to go over that. Here is the temperature, 2 meter temperature from today. This is the, I've got it on, that's the minimum. Here's average, and here's the maximum. And we can see that over the Arctic, we see how much warmer it is. See the green colors over here? It's like the aqua is 0, and when you're going up into the green, that's getting warmer. So all the way over, it's warmer here. This is the air temperature, and then all the way around this ice mass, what's left of it, of the sea ice, which is quite thin, then it's in the greens, going up into the greens as well. When we look at the 2 meter temperature anomaly, this is quite disturbing. Over the Arctic, we see it even going up into the red, and this is This is in centimeters. This is how much warmer it is than it should be. So the brown is 10, and then going up into the red is 20 degrees Celsius warmer than it should be. And we can see that a lot of this area in Russia and Siberia, it's up into the red and the brown. So it's this whole northern area that's in big trouble. We can also see the east coast, or the eastern part of the United States, is much higher than normal. So let's just click around the globe to see how much warmer it is. We have Africa, the northern parts of Africa and the southern tip is warmer than normal. Then going across Europe and Russia. But then this area over here, just this line coming up through Russia and through Siberia, where it's red in the Siberian plain, and then it's this really wide area coming up, and then the upper right hand corner of Russia as well is in the browns. So then here's South America, and it's heading into its summer now, down below the equator, now that the seasons are changing, and it's going to be getting cooler in the northern hemisphere and warmer in the southern hemisphere as the earth is tilting. And so we see the brown here in the southern part of South America. And then here we have Australia. Most of Australia is in the brown, so it's warmer than it should be. And then in the Antarctic, it's flipped. So the eastern part of the Antarctic is over on this left side, and the western part is over on the right side. And the way we orient ourselves is by this little tail, and this is the Western Antarctic Peninsula, and it points to the tail of South America, and that's how you know what side you're on. And this whole western side is warmer than it should be as well. So there's that. And if we look at the precipitation that's going on up there, there's not much precipitation in the Arctic at the moment. There's some rain up here off the coast of Siberia, and then there's a little bit of snow. This blue is snow, and a little bit of snow over here, but it doesn't look like a lot of precipitation. I'm not going to spend a lot of time going over the weather around the world. I mean, a lot of other climate people do that. I'm going to focus on some other things here. Here's our sea surface temperature anomaly, and we can see up here in the Arctic how much redder this sea surface temperature is, and this is in degrees Celsius. It's up into like 5 degrees Celsius warmer. It's really red. And then the white is 0. So the 0 is right here. And then when you go into the blues, it's below where it should be. So just a little bit is below where it should be. It's mainly above. And it's mainly above all the way around the edges of that sea ice is what you're seeing. Here's the jet stream, and we can see it doing a loop, and it's crazy looping, and this is what they talked about when we start having these changes in the Arctic sea ice. We start having extreme weather, and lots of people are reporting on the hurricanes and tornadoes and things like that. That's not my focus here today. we see the jet stream up here coming down this middle part of the Arctic. Here's the North Pole, and then it splits out. So it is doing crazy things, and it is splitting out and looping in strange patterns. Look at this strange loop going over Russia and Siberia, and then another loop down here over India and China. So it's extreme, and we do have extreme weather, and this was predicted, and here it's looping around and does this crazy loop over the United States. And so this was predicted, this looping jet stream. And now we're seeing the effects of these changes. And so I'm reminding people that we're having these changes without the official blue ocean event. So these changes are happening, and it's extreme. And so I don't know how much time we have, but I just don't think we have long, and that people really need to get their spiritual houses in order if you haven't done so already. Here's the Arctic sea ice news and analysis update. This is from yesterday, October the 6th. Here's the sea ice extent. Here's the concentration, and we can see that as it goes darker blue, it's less concentrated, as we saw there. Here is the chart for the Arctic sea ice extent, and it's still really low. It was like, I think I read a report where it was like 6th lowest in history, but 6th and 5th were tied, and the others were really low as well. This dotted line is when it was in 2012, and you can see that from 2012, see, even at this point of the year, it was starting to refreeze, and it's really not doing that. Here's the Antarctic, and now it's becoming spring down there. It's warming up, and so their ice is going to be melting. We can see their concentration. See, it's pretty thin over here on the eastern side. And there's no ice here on this tip of the western Antarctic Peninsula. There's no ice around that tip at all. And there's the ice extent. On my last report, it was down here, and now it's come up a little bit, but now it's leveling off, and it's still quite low. This other heavy line is from last year, 2017, so it's still low. So there's that. And also, on September the 27th, this is their report. So this came out after my last report. This says Arctic sea ice extent arrives at its minimum. Well, they might want to revise this once we get done with all the melting, because it's not done. On September 19th and 23rd, Arctic sea ice appeared to have reached its seasonal minimum extent for the year at 4.59 million square kilometers, or 1.77 million square miles. This ties 2018 with 2008 and 2010 for the 6th lowest minimum extent in the nearly 40-year satellite record. Please note that this is a preliminary announcement. Changing winds or late season melt could still reduce the Arctic sea ice extent, as happened in 2005 and 2010. And here's the overview of their conditions and stuff. So if you want to read all this, I'll leave the link below. And here's the Navy website. We looked at this already. now here's the sea ice concentration, and see it's getting a little more concentrated here in the center as it's getting more red and orange, but it's not concentrated at all over here on this left side that we saw that was all purpley on the thickness. So this concentration, it's fighting for concentration. Here's the sea surface salinity map, and this shows the saltwater concentration, and the red is more saltwater. So there's that. And sea surface temperatures, and we saw the anomaly, but we can see these sea surface temperatures are these are in Celsius, and so they're above zero around the ice, and it's eating away there. And until those sea surface temperatures come down, the ice is not going to come back the way it should. So there's that. I'm going to wait to do, well, okay, we can do NASA Worldview, but here it is from today. I'm going to refresh and see if we got any more data in. No, it's not quite complete. What I found is it comes in, like this area right along here comes in first, and then it comes in more during the day, and this area over here comes in last, and as it comes in, the new data overlays the old data, and so that's why this picture changes as the hours go by. And so sometimes I'll just take a snapshot of this picture here, and in case you don't know how to do that, let me just show you how to do that. You can zoom in, and for instance, here we have this interesting looking cloud over the Beaufort Sea and the Chukchi Sea, and here's Alaska. And so what you can do, you click on the camera, and then you move it to where you want it to go, and then you can adjust what you want to take the picture of, like that, and then you click download. And then there's your picture, and you can copy and paste, you can email, you can save as, and so I'm going to save, well, I'm just going to leave that. You can do a save as, but that's how you do that. You can enlarge it, and we can see the stripes are still over here. I have my own theory about the stripes, and we won't go into that right now. And it's different what other people say. So that's how you can take snapshots here on NASA Worldview. So one thing that I found interesting, and Robin reported on this, but I haven't reported on this yet, so I thought I would today, is these green areas that are showing up. And it's quite green, and I looked back, and the first time I saw it here this year was on September the 17th. And these green, it's usually over areas where there's no clouds, where it's cloud free. See? And they're not real accurate on getting the cloud free, because, you know, it's obvious there's no clouds here, so it's on these sections. And there's also these like jagged edges where these images cut and paste or whatever they do. I don't know what they do, but this is what we have to work with. So Robin reported on this, commenting on these green areas and asking if it was algae blooms. And he put it on a Facebook post, and he said that Sam Carana acknowledged, yes, that these were algae. So I don't know. You know, I don't know. I mean, I'm just looking at this stuff and saying this is strange. This is interesting. This is awfully green. And all of a sudden things are slowing down here. I guess I have too many browser windows open and I'm trying to record, but I shouldn't be having problems. I really shouldn't be having problems here, not with this new computer, so I think I'm having some interference. But if you go back to September 17th here on NASA Worldview, you'll see amazing green all around, and you see green over here too. And see, I'm trying to zoom in. Here we go. And this is all green. This is all green and open water. And I'm trying to go back out and it's not doing anything. I'm freezing up. Now I'm not. Well, yeah, now I'm freezing up. So I don't understand. My computer should not be having any problems at all. So, let's see if I can go back. No, I'm freezing up. See, I'm trying to go back a day. And it's just freezing up. They don't want me to do this. I know that's what it is. There's no reason for my computer to be slowing up like this. And these images are dramatic. They are dramatic with this open water in the Beaufort Sea. Look at this from yesterday. And this is the area that's so warm. Let's see. See, I'm trying to zoom in. It's not doing anything. Here we go. Now, let's take off this sea ice layer here. And it's not showing. It's not working. Let me make sure. Hang on a second. Let me pause this. Okay, I closed out some of my browser windows in hopes that that will help me do some. No, it's just not working. I may have to put this together. I'm going to stop recording for now and I'll come back. Hi, this is Margo. I'm back. I put my CAM's website in a different browser. I think that was slowing it down, but for whatever reason, I think it's working now. This is NASA Worldview from yesterday, October the 6th, and I have this layer turned on. This is ice surface temperature from the day, and when you move your pointer over, you can see the degrees in Kelvin. This is 275 Kelvin over here. Hang on. Okay, so this is like right here in this little yellow-green corner in the Beaufort Sea is like 276 Kelvin. And in case you're not familiar with Kelvin, oh, this is not wanting to load now. Okay, Kelvin. This is how to convert Kelvin tables. This is to Fahrenheit. Robin uses to Celsius. I guess that's what he uses. I mean, that's more common, but you know, I know Fahrenheit better. So 270 is 26.33 degrees Fahrenheit, but they've got this thing here, this converter. So I said this was what, 276. Now see, it's slowing down again for no reason. Now it's not going to work. They don't want me to do this. 276. And it's 37 degrees Fahrenheit. That's what that is. So this whole area, if it's green, it's not going to be freezing, basically, because it has. I did a whole show on this. You can look back through some of my shows where I talk about the sea ice temperature and all this. But if it's this green color, if it's 270 or above, it's not going to be refreezing. It has to be a couple of degrees below the freezing point in order for it to be refreezing. So and the freezing point for salt water is less than freezing point for fresh water, so it's a whole thing. So if it's just an easy way to look at it, if it's chartreuse, it's not going to be refreezing. So, and we have areas down here around Greenland where it's really warm. And what's interesting is that even though we're not getting a satellite image from the North Pole because the sun is setting and all that, it's black here, we are getting the reading for the sea ice temperature. And so this is a way for us to also get an idea of where it's cloud free, because they can only measure the sea ice temperature when there's no clouds. So this is another way we can be monitoring this Arctic sea ice. Even in the winter time, we can be turning on this layer of the ice surface temperature and see, and we're seeing, I mean, it's warm. And Robin did a really good article. He did a bunch of research, and I'm going to present that in just a minute here, and it ties right in with what we're looking at. But he found that the sea ice temperature has been going up every year since 2000, and NASA Worldview, their data goes back to 2000. We can see images back to the year 2000 here, and we're seeing a lot of green around here still, around that circle. But look at this water, this open water here, and these interesting clouds, and I call it the mothership. That's just me. But here it is from the 5th, and here it is from the 4th. But look how open this is. This is the ice edge, and it's lacy and undefined, and it's really thin. It's so thin. This is that thin air. Now there's clouds there, but see that they call this that sea ice there in those little trailing things. So now here's where, see, the data came in later, and they kept changing the picture as it came in during the day. It's so frustrating. So I'll take pictures during the day and then save those so that I can see what it looked like before the new data came in. Now look at this from October the 2nd, where this whole area was just all opened up. Look at that. Now the problem is, where there's sunlight, it's, you know, it's trapping that heat in the ocean, and it's, you know, it's soaking in the heat instead of reflecting the rays of the sun. And so that's another, so that makes another feedback loop. Now why are we having, okay, here we go. Here we go. See how open that is? That's from October the 1st. Here's September the 30th. We'll just go back to my last update, the 25th. Here's the 29th. Now we're getting and here it was clouds. But, so we've had a lot of open ocean there in the last week or 10 days or so. Okay, here's the 24th. But, we didn't have a lot of green here. Let me just hop back to the 17th and I want to show you the green that I saw. And it's right over here on the right side of the sea ice. See this green? And when you zoom in, you can really see it. You can really see it's quite green. And I've just kind of been watching it because I didn't really know what it was, and I didn't want to report on something really that I didn't know what it was, because people would say, what is that? And I'm like, I don't know, and this and that. But I've been looking at it. Robin's been looking at it. Here's some down here. This is green. There, as you move forward in the days, it's more obvious green. Well, now, and it wasn't every day because you can't really see it through the clouds. Here's a big, you see the green here? Once you know what to look for, you can kind of hone in. Here it is. Look at that big green area. That's right on the ice edge. So how can you have freezing ice if you've got algae growing? That's what I want to know. I don't think you can. I really don't. I don't know. You know, I'm in the I don't know camp. Now look at this right here as I zoom in. If you look at this green here, that is undoubtedly green. This is on September 27th. And I don't want to spend a whole lot of time looking at this, but it's okay. Here's the ice edge here. You can see the green coming up. I wonder if it's going up underneath the ice. For all I know, it is. I don't know. For all I know, it is. If this is ice, it looks like that's ice, and we're seeing green underneath it. That's what it looks like to me. So we're in big trouble, folks. Look at this. Look at that huge area of green. See? There you go. And it's stripes. I mean, the stripes are there. You can't see them in every single picture, but they're there. And here we get into that big open area. And then we got a little bit of green over here. A big area of green here. And we're not seeing it all over the place because we've got clouds. And it's usually where you don't have clouds that you can see it. But sometimes you can see it through the clouds. And here's green. See? It's on the edge. On the edge, see? Here's green. And remember we could, like, here's the coastline. Here's Alaska. Here's Barrow. Here's Canada. I mean, that's still Alaska. Canada starts down here. there's the coastline, and then there's brown, and then there's green. That's the sediment. So this winter is, here's yesterday, here's green. See? There's a lot of green. And strange looking clouds. I mean, these clouds just don't look normal. With all these weird ripples in them and stuff. I mean, it just looks weird. Here's the green. Here's Svalbard. Now I've got a very interesting article I'm going to read to you about this area. And then here we are today. Oh, we got some more data in since we've been talking. See, they sliced that in. And the clouds don't match up. See, that's the problem. They just don't match up. So, I don't know. I think we're living in this matrix reality, and they're just showing us what they want us to see. Look at all this green. An open area. Open. Look at that. No clouds when you're seeing all of that green. Alright. Now, I'm going to leave that for a minute. I'm going to go over to my articles. Uh-oh. That's the first time I've had a browser crash on my new computer. You'll love this first article. Giant gas craters discovered at the bottom of the Barents Sea. This is from Science Nordic. This is from yesterday, October the 5th. Cracked gas chambers in the seabed south of Svalbard could blow out and create craters that are up to 30 meters deep, say scientists. Now, let me show you where that is. We were just there. This is Svalbard right here. Right here. And there's Greenland. There's Svalbard. Here's Norway over here. Here's Novaya Zemlya over here. So, let's go back to our article. Here's a picture. Researchers have found more than 100 craters in the seafloor near Bjornia, the southernmost island in the island archipelago of Svalbard. Some of these craters have a diameter of 1,000 meters. That's big. The craters formed when pockets of gas hydrates exploded out of the seafloor. And I've reported on this before, but this is another article reporting on it too. The otherwise flat seafloor between the island archipelago of Svalbard and Finland, Norway's northernmost county, is pocked by massive craters that were only discovered in the 1990s. Now scientists at the Center for Arctic Gas Hydrates, Environment and Climate, CAGE, and I reported on this. The Arctic University of Norway have collected new geophysical data on the craters in the area, but instead of finding just a few craters, researchers found hundreds of them. They range in size from 300 to 1,000 meters in diameter, and they've been blown out of solid bedrock. And they think that methane blew this out. The craters are what remain after a methane gas explosion, or more correctly, gas blowouts. Methane gas chambers formed under the seabed during the last ice age. Up until the end of the ice age, they were capped by a kilometers-thick layer of ice. They have also been kept in place by frozen methane gas, known as gas hydrates. When the ice melted, the gas chambers collapsed one by one. The blowouts may have occurred over a couple of days. So this can just go. So as this melts, they start just falling down on each other and then they blow up. But these blowouts must have involved enormous forces at the bottom of the Barents Sea, since the holes have been blasted out of solid bedrock. The researchers in Tromsø expect further blowouts, as some gas chambers have not yet blown, and others are slowly building up pressure again. Mysterious giant holes in Siberia. Now, a lot of people have seen these holes, these craters, and I think that this could be where sinkholes are coming from. That could be from methane blowing up, and it could be around the world. I mean, we're seeing methane coming up all over the place, on land, under the ocean, I mean everywhere. It says only a few years ago, reindeer hunters on the Yamal Peninsula in northernmost Siberia also discovered several mysterious giant holes in the ground. Russian scientists eventually determined that the cavities had been filled with methane gas and subsequently collapsed. Karen Andreasen, a professor at UIT, thinks the Russians were correct in their assessment. Methane gas in Siberia is locked into the permafrost, and there are frozen gas hydrates in the Barents Sea that ensure the gas is kept buried in the seabed, she says. Otherwise, the process is more or less the same. When the permafrost or gas hydrates thaw, the methane can be released explosively in a gas blowout. Says additional holes have appeared recently, and we now know that the holes are likely from methane. Okay. Andreasen thinks there will be more large blowouts in the ocean floor south of Svalbard as the seabed becomes warmer and gas hydrate reservoirs thaw, but she can't promise that researchers will catch the actual blowout. Okay, now you want to see how warm that is? You want to see how warm that sea surface is? Okay, here's Svalbard, and they're talking about the Barents Sea, which is this whole area. Well, right here is 274.6 K. Right here. And that's where there's no clouds. Down here where we're a little bit further south is 281 K. So this is quite warm. It's quite warm. So, you know, we have to find a day where there's not very many clouds before we can get the sea surface temperature here. Now, there are other websites you can go to and get sea surface temperature. I just, you know, it's just easier for me to work here. Here we go. On October the 3rd, the temperature is at 277 K. So this is above freezing, way above freezing, because it's 271, 273 K for fresh water and 271 K for salt water. That's what it freezes at. But it freezes, but it has to be colder than that for it to freeze. So we can see that this whole sea is warm, And that's where they're talking about this area between Svalbard and Norway, this whole area. And what you're going to see on cams is we have methane coming up. We have methane coming up in these areas. We do. It's coming up now. So let's go back to our articles now. She says the biggest blowouts in the Barents Sea occurred when the ice melted 12,000 to 15,000 years ago. Andreasen says there is probably even more methane gas locked in the seabed around Greenland and in the Arctic Ocean than is found in the Barents Sea. That could lead to some extremely large craters. And that's the end of that article. And I'll leave the link below. So, before we go on with articles, let's just pull up cams. And let's look at methane. And I already have methane loaded up. And I've got the North Pole loaded up. And we have data back for 3 days, but I took it the base time from Friday, which is the most recent data. I already have the movie loaded up. And so as we're looking here, here's Svalbard, here's Greenland, here's Novaya Zemlya, this is the Barents Sea. And then here's the North Pole, and you can see it's darker it's being released over the North Pole right there. And it's being released over here out of the Kara Sea. And here's the East Siberia ice shelf. So let's see if this will run without me having to reload it. And you can see it's what's going on with our methane up there. And it's releasing from here north of Greenland. You can see it there. It's releasing from south of Svalbard. It's releasing all in this ocean here. It's coming up. So that article, they're telling us what's happening. They're telling us. And then see, it's coming up over here. So it's a lot of red and orange. And then of course we've got China and India that's like covered up in methane. But I really want to focus on the Arctic today. And some of the ozone as well. So there's that. Now I want to go back to my articles because I have some real interesting articles today. Now I'm hopping over to Robin's blog, See More Rocks, and you can find his blog at robinwestenra.blogspot.com. And this blog is from today. He did some research. Let me just start with this and then we'll talk about it. And he says much higher than normal temperatures at the North Pole. Much higher temperatures at the North Pole at the end of the melt season. He says these are the temperature anomalies measured at the North Pole for the past 7 days. He says, I've taken a slightly different tack on this and used a layer available on NASA Worldview for ice surface temperature, which indicates those areas which are cloud-free, as well as measuring the temperatures in degrees Kelvin. And this is what I was just showing everyone. The temperatures are given a color coding, which is available in the insert, as well as the actual temperatures in degrees Kelvin where I point the cursor. To see how to convert degrees Kelvin to Celsius, go here. And you click on that link and it goes to a Celsius converter. So what he has pulled up is NASA Worldview from October the 5th on the Arctic, and he's got that sea surface temperature ice surface temperature layer turned on, and that's what I just showed you. And he says, I've taken temperature readings on as close to the same date for each year from 2000 to 2018. These figures are usually available as a range, but for simplicity, I've taken a minimum temperature measurement as close to the North Pole as I can. So he's taking minimum. I like to go to maximum, but he likes to go to minimum. So, because that's where it's going to be the coldest. These figures are therefore necessarily indicative and approximate. What they do show is that with the exception of 1 year, 2010, the minimum temperature in the North Pole is over twice the minimum temperatures measured for other years. Apart from the 1 year, 2010, the range of minimum temperature was, on average, from the mid-20s minus approximately minus 13 degrees Fahrenheit to over 30 degrees Celsius or minus 22 degrees Fahrenheit. Yesterday I measured the temperature at the pole as minus 9 degrees Celsius or 16 degrees Fahrenheit with a minimum of minus 12 degrees Celsius or 10 degrees Fahrenheit. So here he made this chart starting with 2018 going backwards, and so this was all around October the 5th, and he saw the minimum of 261 degrees Kelvin or minus 12 degrees Celsius, and so it's freezing at 0 degrees Celsius. In 2017 it was a huge drop, 248, well, it's not as huge as what we're going to find later, but it was 248 or minus 25 degrees Celsius. 2016, 251 or minus 22 degrees Celsius. And so you can see as you look down here, then it went down to 241 in 2010, 241 in 2011. It was a little higher in 2009, 263, and then it went down to 2008, 245, 2007, 245, 2006, 253, 2005, 223, 2004, 240, 2003, 244, 2002, 259, 2001, 234, and 2002, 23. So we see a huge difference from 2000 to 2018. So it was minus 50 degrees Celsius at the minimum at the same time in 2000 and minus 12 degrees. So that's a huge difference. So this is why the Arctic is not refreezing. And he says here is a representation for 2 previous years. And here's the October the 4th, 2017. And so as we saw, the green is not freezing, but once you get into the blues, it's starting to freeze. And so we can see up here, we can see a lot of greens, just a lot of greens, even right at the North Pole. So it's very, it's just not coming back yet. Here's last year, and here's year before last, or no, here's 2000, and see, it's a lot more blue, but they had the greens there too. Despite the lack of a record in sea ice extent, these figures point to a major departure from previous years. The Arctic ice is not refreezing. No, and it's having trouble just staying where it's at. That's what I'm finding. Okay. Now here's another blog post from Robin. I was sending him pictures of the Beaufort Sea and the strange things I was seeing, and so he did a blog post about it. Strange, and this was from October the 4th. Strange images in the middle of a large area of blue ocean in the Beaufort Sea. And he says, I've not seen a single comment about the large area of blue sea in the Beaufort Sea, let alone some of the other strange phenomena. Strange what reveals itself when you monitor things over a period of time. More strangeness in the Beaufort Sea. We are talking about the large area of blue sea in the upper left quadrant below, this area here that I showed you. There's October 3rd. None of the following photos have been manipulated in any way. It is simply what one sees when one zooms right in. Those streaks look suspiciously like contrails to me. It is the very first time in the weeks I've been looking that I've seen anything remotely like this. And this is actually gone. This was a close-up that I took a picture of and sent him, and so he put it in the blog post. And when you go back in and zoom in on those days and try and find these, a lot of them are gone. So here it is, and here's another one, and here's one that's like breaking apart. You know, you can call it a chemtrail too. I know a lot of the climate people don't want to say chemtrails, but you know, I think geoengineering is well advanced. And here's over an area of broken ice as well. See, look at these straight lines over the open ice, over the ice. And then today there's a large area cloud, and this is where we saw a cloud a few weeks ago. But now look at this area here. I zoomed in and I sent him this picture. Now when you go back to NASA Worldview, this picture is not there because they've sliced and diced with overlay. So this is another good reason to take a snapshot like I showed you and save it, because these images do change. And here's a close-up of that area, that top part of that cloud. And I don't know what that is, but this is the cloud, and this is like a little island in the water. And why the cloud is separated around that is beyond me. And then this weird stuff, it looks like it's being beamed. But that's all I can say. So stuff is happening, and strange things are happening in our environment, in our world, that we just can't explain. We just cannot explain them. Strange things. Now, here's another article that I'm going to share. This is from October the 5th. This is from Zero Hedge. Bizarre cosmic rays are shooting out of Antarctica, and physicists can't explain it. Just over 10 years ago, NASA-affiliated researchers set out to observe cosmic rays showering down on Earth from above. During the experiments in Antarctica, physicists found something unexplainable, something that could change everything we think we know about physics. So here's their thing down in Antarctica receiving the cosmic rays. The Antarctic Impulsive Transient Antenna, or ANITA, balloon experiment began in 2006 when the balloon spent a month hovering over Antarctica's ice. Using sensors, Anita began detecting high-energy neutrinos interacting with the ice sheet below. Neutrinos are unique in that they don't lose energy as they disseminate throughout the universe. Because of this, neutrinos are capable of providing humans with a peek into the vast expanse of the universe that would otherwise be unavailable. During Anita's time in the Antarctic, it detected never-before-seen upward-pointing cosmic ray-like events. The rays detected had horizontal planes of polarization, which may suggest they didn't originate in space. The detection of these events means a new type of particle may have been evading detection by sophisticated particle accelerators since we began using sophisticated particle accelerators. Can you say CERN? Thanks to the Standard Model, physicists have known that cosmic rays are capable of reaching and penetrating space. However, according to the model, those rays shouldn't be able to pass all the way through our planet. So are the anomalous high-energy particles measured by Anita originating from Earth, or are they actually passing through Earth? Some existing physics models that exist beyond the Standard Model involve theories that the interactions between cosmic rays and ice actually produce micro black holes that open into small dimensions. Anita's first mission didn't detect the black holes, but it did detect the Ascarian. Last week, a group of researchers posted a new theory about the rays measured by Anita. The group, led by Pennsylvania State University physicist Derek Fox, suggests Anita may have found evidence of a particle that lies completely outside of the Standard Model of physics. The Standard Model has been successful as long as we've been using it, but it hasn't been able to explain everything. For example, things like gravity and the accelerating expansion of the universe are not adequately explained by the model. That's where the physics beyond the Standard Model, some of those theories include string theory and extra dimensions. Fox's theory relies on a type of BSM called supersymmetry. We argue that if the Anita events are correctly interpreted, then they require some beyond the Standard Model particle. The likely properties of the particle seem consistent in at least some ways with the predicted properties of the state in some supersymmetric models. In order to delve further into the unknown when it comes to these upward-pointing cosmic rays, they must also be observed at other locations. Fox and his colleagues took the first step when analyzing data from the Ice Cube Neutrino Observatory in the Arctic. Did you know there was an Ice Cube Neutrino Observatory in the Arctic? I didn't know that. That's all news to me. Despite the difference in detection systems, 3 events were identified in the data that were analogous in the cosmic rays observed by Anita in Antarctica. Fox's theory is only one interpretation of the Anita data. The 4th Anita mission was launched in 2016, and researchers are hopeful that its data, once completely analyzed, will reveal additional examples of these unusual cosmic rays. So, we have neutrinos, we have new cosmic rays, new particles, new things are happening all the time, and I believe it's because we're moving into these other realities and these other dimensions. And I haven't talked about this a lot, you know, in the climate science stuff, but I think it plays in together, and you know, we need to have our minds open to other possibilities. And then this is from Fox News. This is a new article that came out when this, September 18th. And this goes right along with the neutrinos. This is a neutrino lab they're setting up near Chicago. This experiment will shoot ghostly particles through Earth and answer why we exist. This is by Don Lincoln, senior scientist of the Fermi National Accelerator Laboratory, University of Notre Dame, from Live Science. Look at that picture. The photo dune detector was filled with 800 tons of liquid argon. Credit of CERN. The study of the subatomic world has revolutionized our understanding of the laws of the universe and given humanity unprecedented insights into deep questions. Historically, these questions have been in the philosophical realm. How did the universe come into existence? Why is the universe the way it is? And why is there something instead of nothing? Well, move over philosophy, because science has made a crucial step in building the equipment that will help us answer questions like these, and it involves shooting ghostly particles called neutrinos literally through the Earth over a distance of 800 miles, nearly 1,300 kilometers from one physics lab to another. Now, before I go on with this article, do you see how this dovetails with this other article about finding neutrinos in the Antarctic? They're just now coming out with this article in Fox News, but it's telling me that we're already doing this. Somebody is already doing this somewhere else. Maybe in the Antarctic. Maybe there's underground bases there. I mean, a lot of people think there's a big secret underground base there. Maybe it's already happening. And I did read somewhere that there is a neutrino lab in the Antarctic. I did read that. I should have bookmarked it. I didn't. But anyway, this is a neutrino lab that they're building, and it's going to be outside of Chicago. And so I'll leave the link below. This is going long. I don't want it to go too much longer. But you know, we're doing stuff that we don't know what the consequences are, you know, and you know, they could blow us up, they could take us into a pocket reality, they could, I mean, they just don't know. And if you read my ebook on Ascension, Timeline Shifts in Consciousness, it's all channeled messages that I got in 2008 and 2009. It talks about all this stuff. These were channeled messages that I got in from the soul of the earth, what I call the Great One, and from my inner teacher, Brother Juan. And they talk all about how at the end the bad guys are going to try to take Earth into a pocket dimension and a pocket reality. And this is they're telling us, it's right here. This is what could happen. And now, my last website to show you before we look at CAM some more is Space Weather. This is a good website, and we're in the middle of a geomagnetic storm that's in progress because of we have a coronal hole, this is the sun, and this is a big hole in the corona in the sun, and it's spewing out cosmic wind, and it's earth facing, and so this is why we've got this geomagnetic storm. It can cause earthquakes, it can cause volcanoes, it can cause extreme weather, it can cause disruption in satellites, in cell phones, and all kinds of stuff. And we have a comet coming, and so I will leave the links below to all of that. So I'm going to close out that browser, and now let me close out this other browser just so I don't have any difficulties while I'm running cams for you. We already looked at methane. I have ozone loaded up on the South Pole, and our base time is from today. Let's see, is that's okay. And we can see that the actual thinnest part is right, it's over the land mass of Antarctica, and it's actually gotten down into the black, and black is 100 or lower DU Dobson units. That's the lowest I've seen, but I haven't been tracking it until this year. So we see this black line that's delineating between 220 Dobson units and below, and that's a reference that NASA decided that they found it. They'd not seen it lower than that before they found the ozone hole. But see, it's still, it goes black in the middle, in the center, but the ozone hole should be coming back. It shouldn't be quite as thin as we get more daylight down there. It's actually at its thinnest right around now. It goes to its thinnest around the first part to mid part of October, but it is disturbing because it's thinning all the way up to South America. You can see. So another thing that I'm going to show you is that it's also thinning worldwide, and the ozone layer is going away. It's not coming back. It's seriously not coming back. And we can see this huge thinness at the bottom of the world, but we also can see, like where the aqua is, that's the thinning, and it's all the way up here through the Pacific Ocean, and then the green is thin. Anywhere it's green or aqua, it's below where the average where it should be. And then when you see it get into the yellow, they consider 300 Dobson units to be average. And then when it gets up into the red, that's better. But we can see that most of the Earth that's, you know, around the mid latitudes, and it's green. It's in the green to blue green, and we can see it thinning going up into Siberia, and then the aqua, and in the aqua up in Alaska, up in Canada. It was up here in Alaska, but it's moved over. But and as the seasons change, this ozone layer on the South Pole will thicken back up, and it will become thinner over the North Pole, because that's where it gets colder with no sun. That's where it goes thinner as well. But this is disturbing about it getting so thin. around the mid area of the planet. It's getting thinner, but parts are coming back as well, or thicker, and I don't know why that is. I cannot explain it. And now I have sulfur dioxide pulled up, and then we'll wrap this up. And I've put the base time as Friday because what we're seeing, and I have the Pacific, just the Pacific view pulled up here, and what we're seeing is where these reds are, this is a large release of sulfur dioxide. Usually we see this with volcanic activity, and it can come up when we have earthquakes as well, but we've had a lot of earthquake activity, a lot of large earthquake activity in the last few weeks, and all around the Ring of Fire. And I'm not going to show earthquakes, I'm not going to do any of that, but what we see is more volcanic release or sulfur dioxide release from Hawaii and from Mexico, from Alaska up here, over here on the west side of South America. There is a large release over here in Indonesia. I'm thinking that could have been with the earthquake activity, and up here in Papua New Guinea, and then toward the end of the period, it's releasing up here in China. It's very red up here in China. I'm not sure what that's from, whether it's just from pollution or if they have some geologic activity going on up there. Sometimes we'll see these releases happen before the earthquakes go off or before the volcanoes go off. But a large release of sulfur dioxide is indicative of geologic activity, either earthquakes or volcanoes. So I'm going to wrap this up for today. My name is Margo. My website is margoshealingcorner.com. Time is very short. No one knows the day or the hour. I recommend that you get right with God and Jesus and make your decision on who you're going to go with when it comes time to choose, because when we leave this earth plane and head up into the spirit realm, it's just going to be in the blink of an eye and you won't have time to choose. So make your choices now. Time is short. I love you guys, and until next time, God bless everyone. Go in peace, and goodbye.